Good evening, everyone. This is M.Devi Prasad of M.Tech Embedded Systems from Vellore Institute of Technology, Chennai. So, today we are going to discuss about optical crank position sensor. In that, we'll see what is a crank position sensor, what is the need for crank position sensor, location of crank position sensor, types of crank position sensor, and their working. Along with that, we'll see one of the applications of crank position sensor. So, what is a crank position sensor? A crankshaft position sensor is an electronic device used in internal combustion engine to monitor the rotational speed and the position. Now, next we'll see what is the need of this crank position sensor. This crank position sensor is always used to control the flow of fuel in the fuel injection system and also to maintain the timing in the ignition system. Now we'll look into the location of the crankshaft position sensor. This crankshaft position sensor is typically located on the front of the engine on the timing cover, and the sensor body of this crankshaft position sensor is placed in front of the engine. And when we look into the types of crankshaft position sensor, there are almost three types of crankshaft position sensors. One is Hall effect sensor, inductive type sensor, and the optical type sensor. Now, first one is Hall effect sensor. I'm sorry, I'm not going to explain you about Hall effect sensor because one of my friend M.Devi, she has very clearly explained you about this Hall effect sensor in the given link below. So whomever wants to know about this sensor very clearly, they can just go through this link and learn about the Hall effect sensor. Now, next we are moving on to inductive type crankshaft position sensor. This inductive type crankshaft position sensor is extensively used in automotive industries right now. Now we look into the construction of the crankshaft position sensor. This crankshaft position sensor consists of toothed wheel and a sensor body, and this sensor body internally consists of a winding coil which is placed between a magnet. Now we'll look into the working of the inductive type crankshaft position sensor. So when we look into the working of the crankshaft position inductive type crankshaft position sensor, this looks something like this. And whenever this toothed wheel starts rotating, and when the permanent magnet which is present in the sensor body will be generating a magnetic field, and whenever this toothed wheel starts rotating, this toothed wheel will deflect the magnetic field which is produced by the permanent magnet. So whenever this magnetic field is deflected by the toothed wheel, this deflection will create a EMF in the winding coils. This deflected EMF which is generated in the winding coil, that can be observed in the voltmeter, and this voltage is converted into pulses and then it is fed to ECU, so that based on that pulses generated we can control the rotational speed or measure the position. This is how an inductive type crankshaft position sensor works. Now we'll look into another type of crankshaft position sensor, that is our main concept, optical type crankshaft position sensor. And when we are looking into the construction of the optical type crankshaft position sensor, we have a photodiode with a pair of photodiode and a slotted wheel and a light source. Why we are having a slotted wheel here is, as the light passes through the as light source is on, we have to send this light to the photodiode. So for that we need this slotted wheel. Now we'll look into the working of this optical type crankshaft position sensor. So what happens is, like, whenever power supply is given to the light source, a light beam is generated, and this light beam which is generated is made to pass through the slotted wheel, and from the slotted wheel this light beam will fall onto the photodiode. And as we know that we have a pair of photodiodes, this pair of photodiodes will generate different voltages when the light falls on them. To be clearly explaining to you, we know the working of a photodiode. What it does is, it converts the light, the amount of light which is fallen on it, into the voltage. So whenever the slotted wheel is rotating, this will deflect the light, and when the light is deflected, that will alternatively fall on the pair of photodiodes, and whatever the photodiode it is getting the supply, this will convert that light into the voltages, and that voltages are observed in the output monitor. And this output voltages which are generated, that are converted into pulses, and then these pulses are fed to ECU so that we can measure the rotational speed and the position. This is how an optical crankshaft position sensor works. Now let's see one of the applications of this crankshaft position sensors. We know Mercedes-Benz is one of the top class companies, and one of the engines called M161 engine of Mercedes-Benz ignition system uses inductive type crankshaft position sensor. This crankshaft position sensor is located in the opposite side of the crankshaft pulley and the triggers of the pickup wheel tooth, which is equipped with 62 teeth with a gap and 2 teeth with 360-degree spacing. It means that the toothed wheel consists of, usually it should consist of 60 tooths, but what happens here is it consists of only 58 tooth, and this 2 teeth will be left as a gap. This is how the construction diagram of the crankshaft position sensor in M161 looks. So let us go into the working of this. This crankshaft position sensor, which is present in this M161 engine, this provides a reference signal of 58 teeth. As I told you that there will be a space of 2 teeth gap, so the remaining 58x reference signal is produced by the crankshaft position sensor. During one crankshaft revolution, 58 crankshaft pulses will be produced. The ECM uses this 58 pulses as a reference signal to calculate the engine RPM and the position. The ECM constantly monitors the number of pulses on the 58 reference circuit and compares them to the number of the camshaft position signal pulses being received. If the ECM receives an incorrect number of pulses on the 58x reference circuit, this is called as failure code, and the failure code will be set. Now let us look into the different failure codes that are used in M161 engine. This is the table that explains about the different sorts of failure codes in the M161 engine. If the failure code is 17, that represents that the crankshaft position sensor has a failure, signal failure. What is the trouble area of it? Even though the cam position recognition is normal, so no crankshaft position signal is recognized. Now when we look into the failure code 18, what happens here is RPM of the engine is greater than the maximum value. So now we look into the trouble area. Here what happens is, when more than applicable revolution values are implausible to 62, it means that it is getting more than 58 pulses than the reference signal. Now let's go look into the failure code 20. It means that the gap recognition failure. What happens here is the gap which is that 2 teeth gap which is present in the pulley, that is not getting recognized, so that causes an error. Now let's look into the failure code of 67. It means that now, right, till now we have seen that pulses are not getting recognized or the spaces not getting recognized. Now what happens is like even the pulses are not getting recognized, the sensor position is not getting recognized. It means why this error is caused is because of the crank angle of the sensor. And the maintenance hit for all these types of failure codes is almost the same, that is monitoring the actual RPM through the scan tool, inspection of the ECM pin in 199 about short circuit with a bad contact, inspection of the clock position sensor, inspection of the air gap between the sensors and drive plate, inspection of the drive plate, and inspection of the ECM. Now let's go get into some of the inspections. Now we are going to look about sensor resistance inspection of the crankshaft position sensor. What we are going to do is we are going to disconnect the coupling of ECM while the ignition switch is off. Now we are going to measure the resistance between the coupling terminals pin number 99 and 100 using multimeter. If this value rise in the range of 1050 to 1400 ohms, that is fine. If there is an error, that can be found out with this. Now let's get into the inspection of the output waveform. Measure the same output waveform between the pin numbers 99 and 100 using the scan tool or the oscilloscope while the engine is cranking. Now you can observe the waveform. Whenever there is a difference occurs, and that waveform will be deflected, and this gap that B represents the missing tooth 1 and 2 in that 60 cycles. Crankshaft positions, and now we are going to look into the insulator resistance. Now disconnect the ECM, switch off the ignition, and now put the resistance between the 100 and 69, pin number 69 and 100 using multimeter. If the if it is greater than the specified value, that is 20 kilo ohms, then it is said that there is some problem with the crankshaft position sensor. Thank you. Thank you for giving me this opportunity. Thank you.